Mrs. Woolley. I miss you all. I hope you're having a great day. I just want to review direct variation with you. I know that it's been giving you difficulty. I want to assure you that you have all the skills you need to successfully master this concept. It's really not as bad as it looks. It's just new vocabulary. Sometimes new vocabulary can be challenging for us. So just give yourself that time that you need to make sense of this concept. I know you're going to understand it before too long. Okay, so I'm going to use an example of Mr. Gym Guy. And Mr. Gym Guy is a personal trainer extraordinaire. So for one client, he charges $45 for a half hour, and two clients, $90, and so on. And I've organized this data in a table for us, and we're going to look at this data and see why the cost varies directly with the number of clients. So whenever we have data organized in a table, we like to look at finite differences in each column. So let's look for those finite differences and see if we can see a pattern. So if we look at the number of clients column, as we go down, we can see we're increasing by a unit of 1. And then if we look at the total cost on the right-hand column, we can see that we're increasing by 45. So this 45 to 1 is a constant rate of change. Now I know as soon as you hear constant rate of change, you think slope. Absolutely. So now we're going to take our slope and we're going to multiply it by the number of clients and compare it to our cost because we want to model this situation with an equation. So let's take our 45 and multiply it by 0. That equals 0, which happens to be our total cost as well. 45 times 1 equals 45. 45 times 2 equals 90. 45 times 3, 135. And 45 times 4, 180. So we just need to take our number of clients, multiply it by that constant rate of change of 45, and it happens to equal the total cost. So if we were to write this in slope-intercept form, y equals mx plus b, our starting value is 0, because if Mr. Gym Guy doesn't have any clients, he doesn't make any money. So here we go, y equals 45x. So far, I don't think you've heard anything new. We like to represent our data graphically, so if we would plot these 5 ordered pairs, we can see that they would follow in a line. Of course, we're not going to connect all the data because we know that this is discrete data. We could use that dashed line, but I'm going to leave the data just like it is. So I can see in the table here that the y-intercept is 0, and I can see here that this data passes through the origin. But the truly beautiful thing about a direct variation equation is the pattern that we're going to look at horizontally. This is not something that you are used to doing at all. This is a brand new idea. So we're going to look at taking the ratios of each ordered pair. Now remember, ratio is just a comparison of two numbers by division. I'm not going to start with the ordered pair 0, 0, because honestly, that is not going to help us at all. But let's look at this ratio right here, 45 divided by 1, and 90 divided by 2. Geez, that's also equal to 45. 135 divided by 3. Check it out in your calculator. Yep, that one's 45 too. And 180 divided by 4. That is also 45. So I have this constant of variation or constant of proportionality. Now, when I think of two ratios that are equivalent, that's a proportion. And that's the constant of proportionality right here. So 45 is equal to 90 divided by 2. It's also equal to 135 divided by 3 and 180 divided by 4. So this is a special type of linear equation. So besides seeing that the y-intercept is 0, so if we were to write this in slope-intercept form, we'd write it as y equals mx. We also see that that slope is the same as the constant of proportionality or constant of variation. So the slope gets a special name. We call it k because it's a special type of linear function. And remember that k is just the constant of variation or the constant of proportionality, and it's just the slope. So In closing, just remember this is a special type of linear equation. It's going to pass through the origin, and we see this beautiful pattern when we take the ratio of each ordered pair. You got to love it. Math is just so cool. So I'm really proud of you. Keep working hard, and I'll see you soon. Have a great day.